The second portion of this focus lesson is discussing whether we have infinite solutions or no solution. There are only three options whenever you work out a system of equations. You either have a system of equations that do this, that cross. Remember that the solution represents where the lines cross, so you have one solution, which is what we usually encounter whenever we get that point, we get that answer. We also have ones that are parallel lines, and if you remember anything about parallel lines, it means that they never cross, and so you have two lines that are going the same direction. In this case, we have no solution. And in the rare situation, sometimes you have a line that is stacked on top of another line, which, of course, if you have that going on, they have so many solutions that we say there are infinite solutions. So we're going to take this one out because, of course, we understand how to do one solution work. We just need to figure out how do we determine whether it has no solution or infinite solutions. And what you find out when you work out the questions like that is that something always kind of happens that tells you you're going to have something weird going on. So let's look at A, which gives us x equals negative 2y plus 4 and 3.5x plus 7y equals 14. Now the variable that we have alone here, if you remember doing that just a second ago, is our x. Our x can be traded out for negative 2y plus 4, and so we come down here and put another box around that x. 3.5 is in front of the box. Trade that out for negative 2y plus 4, and then rewrite the rest, which is plus 7y equals 14. And when we go to do this work here, we get 3.5 times 2, which is 7. So since that's a negative, it will actually be a negative 7y plus 3.5 times 4 gives us 14. And then the rest of that is plus the 7y equals 14. So this makes negative 7. That makes 14. Then the rest of the stuff comes down. And what happens is weird. That tells me we're going to have either no solution or infinite solutions, is that when we go to combine our like terms, notice that these two items are opposites, which means that they end up canceling out. And when they cancel out, we end up with 14 coming down the left side and 14 coming down the right side. And that is our indicator that we're going to have either infinite solutions or no solutions. And what you use to tell you that is to ask whether this is a true or false statement. Since this is a true statement, that 14 is actually equal to 14, that means that it works, and it means that we have a whole lot of solutions, which means we have infinite solutions. So again, if your variables disappear, you either have infinite solutions or no solution. If the work that you get is true, then you're going to have infinite solutions. If we look at letter B, you have y equals 3x minus 11, and you have y minus 3x equals negative 13. So let's look at this and see how it works out. Here y is by itself. 3x minus 11 is what it's going to be equal to, and we're going to trade it out right here. So this is going to turn into 3x minus 11 minus 3x equals negative 13. Going off of that, since there's nothing in front of those parentheses, I can just go ahead and combine my like terms. But notice again, these two are opposites. You have a negative 3x and a positive 3x, which means these two things cancel out. What comes down the left side is negative 11. What comes down the right side is negative 13. And again, because that disappeared the way that it did, we have to ask ourselves, is this infinite solutions? Is it no solution? And that comes down to, is this a true or false statement? Of course, this is a false statement, which means that there are no solutions. And so what I need you to do is take a few minutes to do 26 and 28. Ask questions, of course, before you do that, but take a moment to do 26 and 28 and see if you can make the proper decision as to what's what. Other than that, good luck.